Okay, welcome everyone to the second set of videos we will have on Chapter 9 material. We're going to pick up where we left off. So the first 6 videos covered quite a bit, but we finished with units of concentration. So we introduced, we'd actually looked at units of concentration back in Chapter 7 briefly, but we really got into it here looking at the weight volume percent equation. Okay, right here, and then also molarity. Talked about what those are, how to prepare a solution, and then we worked some problems. We finished with this problem where we calculated a molarity. And now, moving on, we're going to add to this, we're going to recognize how we can use molarity as a conversion factor. So I'm going to write what molarity is. Okay, it says molarity equals moles of solute over moles over liters. Okay, a volume of solution on bottom, moles of solute on top. So molarity relates two properties: moles, which is an amount of something, to the volume that amount of solute is in. Okay, the volume of solution. So it relates moles and volume, moles to liters particularly, just like density relates grams to milliliters. Okay, just like molar mass relates grams to moles. Molarity is just a term talking about the relationship between moles and liters. So because we now have defined a relationship, and we can do this for any substance, any solution, if we know the concentration, we can know the amount of moles and the volume of that solution, moles and liters. And so we can use this to convert between these two properties, moles and liters. So we're going to do that with this problem. I think this problem is also in your textbook, but let's just read it and then we'll solve for it. So it says a blood alcohol content of 0.065 molar is enough to induce a coma. If the total blood volume of an adult male is 5.6 liters, so one adult male has 5.6 liters of blood roughly, then how many grams of alcohol are necessary to reach this concentration? Wow, what a great question. How much alcohol necessary to put someone in a coma? What we're going to do, though, as I put this figure in here, we're going to follow this figure step by step. Okay, we know the given volume of blood. Okay, it's in our problem. It is 5.6 liters. Because we know the molarity, okay, of alcohol content in blood, that's enough to induce a coma. We know this molarity. We can convert and figure out moles of alcohol. So what this concentration is telling us, the molarity right here, it is saying 0.065 moles of alcohol per 1 liter of blood. Okay, that is equal to 0.065 molar. Okay, so this 0.065 molar, that's what this means. It means 0.065 moles of alcohol per 1 liter of blood. Alcohol is the solute here. Blood is the solution or the solvent. So we're going to use this to convert from, we have liters of blood here. We're going to use this to go from liters of blood to moles of alcohol. All right. Then we'll use the molar mass of ethanol, which is 46.07 grams per mole, okay, to convert to grams of alcohol. ETOH, but you're wondering what this is. This is ethanol, which is alcohol, okay? So this is alcohol. It's just a different way to represent it. Okay, so I didn't leave us a ton of space, but let's see if we can kind of do this problem down here. So we're going to start out with the volume given, 5.6 liters of blood. And the next step is step 1 right here, is we're going to use molarity as a conversion factor. So I'm going to convert, I'm going to write liters of blood on bottom for every 1 liter of blood. It is 0.065 moles of alcohol. So now liters of blood will cancel out. And lastly, we want to know how many grams of alcohol. The question up here says how many grams. So we're now going to use the molar mass. This is the molar mass of alcohol. right here, to convert from moles to grams. So we'll write for every 1 mole of alcohol, because we want moles of alcohol to cancel, we have 46.07. I just looked this number up. You could calculate it if you had to, because you are given the chemical formula for ethanol or alcohol, but it's that many grams. Alright, so now we can solve for our answer. We will just do 5.6 times 0.065 times 46.07, and what you find is that it takes 16 point, if we round, it should be 16.8 grams of alcohol. Okay, so that is our answer right there. So this is an example of how we can use molarity as a conversion factor to convert between moles and liters. Okay, moles of solute, liters of solution. Okay, another chart. This may actually look familiar to you. I'll kind of show you how we have used something similar before back in chapter 6. But what it's saying here is the use of molarity in stoichiometry. Now, what is this word stoichiometry? I really don't use it a whole lot. It's just saying when you have a balanced equation. Okay, so right here in this green box, we kind of have this balanced equation. And when you have a balanced equation, we know that we can get a mole-to-mole ratio from this. We can use molar masses and mole-to-mole ratios and convert and find out different information about different products and reactants, and we've done that before. We did that back in chapter 6. That's essentially what stoichiometry is. It's using information from a balanced chemical equation to convert between reactants and products, essentially. And we can also do that with molarity, okay? So if you guys remember from chapter 6, you've seen me write this on the board several times. If you start with the mass of substance A, we could convert to moles of substance A. We could then convert to moles of substance B, and we can go back to mass of substance B using molar mass of A, using a mole ratio, and using another molar mass for substance B. Okay, so that's what I was saying, is this figure might look similar to the one we used to draw for chapter 6, which involved molar mass. But here, we're essentially doing the same thing. Instead of mass, though, we're working with volume in moles, not mass and mole conversions. Okay, so let me erase this because I don't want to confuse us. Just wanted to point out that similarity. We're not doing really anything so different here. We're just using molarities instead of molar masses, and we'll walk through an example problem. So anyways, this figure is just saying if we have a balanced chemical equation that is all solutions, okay, and we are given a volume of solution for substance A, whatever substance A is, maybe it's a reactant, maybe it's a product. If we know the molarity of that same solution, we can use molarity as a conversion factor to convert between moles and liters, okay? So if we're given a volume, we can use molarity to go from liters and convert to moles of substance A, all right? Then, once we have moles of substance A, we can use a mole ratio. It's written for you. I didn't see that. You can use a mole ratio to go from moles of A to moles of B. Lastly, we can convert from moles of B back to volume if we need to know how many milliliters of our solution B we need. We can use, again, molarity, which is moles per liter for substance B, okay? So that's